I'm going to try and keep this a little bit shorter than the last video. We're talking about compositions of functions described on these pages in text and test 5. So if you have a function like g of x is x squared, you know, g of 5 is 5 squared, there is 25. You know how to do that. F of x is x plus 3. F of 5 is 5 plus 3 is 8. Okay, so we know how to do that. If you're given notation that looks like this, or this, or this, okay, it's g after f, is how that's often said. So g after f of x. What it means is evaluate f of x first, and then plug your answer back into g of x. Okay, so for us, it might be g of f of 5. Okay, well, you'd say, well, that's g of f of 5 is 8. So g of 8. And then 8 squared is what we're getting there, is 64. So g of f of 5 is 64. And in general, you can create a rule to calculate this in one step. You can say g of f of x is, well, it's something squared, isn't it? And it's x plus 3 squared. So if you were given g of f of 5, another way you could do it is you could say, well, 5 plus 3 squared, and that would also give you 64. Okay, so that's called a composition of two functions. Just some other notation you might see here as well is you might see f squared of x, and that means f of x, sorry, f of x. Okay, so it's plug your value for f of x in. So for example, f squared of 5 is, well, f of 5 is 8. So it's the same as f of 8. And then f of 8 is 8 plus 3 is 11. So it means you're doing the function twice. Stop there. Try g squared of 2 there. See how you get on. Okay, hopefully you've said that's g after g of x, or g of 2. Something like that, which is g of 2 squared is 4. So g evaluated at the point 4, and 4 squared then is 16. Okay, go to page 241 and look at question 3. The two functions are defined as f of x is 2x minus 1, g of x is x squared plus 2, and they've asked us to evaluate f after g of minus 2. So what you'll do there is plug minus 2 in here. You get minus 2 squared is plus 4, plus 2, that's 6. And then you plug the 6 that you get into this second function. So you'll get yourself 2 times 6 minus 1, which is 12 minus 1 is 11. Just to show you that, sorry, that's going to be f of minus 2 squared plus 2. Okay, that's g of x, or g of minus 2, which is f of 4 plus 2 is 6, and f of 6 is twice 6 minus 1. So that's 12 minus 1 is 11. Okay, I'm going to leave you to do part 2 yourself. Part 3 is f of g of x. So that is going to be g of x is x squared plus 2, and then f of that is 2 times x squared plus 2 minus 1. Okay, there's our rule for f of x, 2x minus 1. Excuse me. 2x minus 1. Okay, I mean, you've plugged your rule for g, which is x squared plus 2, into that function. And to tidy that up, that's going to be 2x squared plus 4 minus 1 is 2x squared plus 3. And the fourth part is g of f of x. Well, that means you do f of x first, and it's g of 2x minus 1, which is, our rule for g is x squared plus 2. So that's going to be 2x minus 1 squared plus 2. Okay, and what do you get there? Square the first, square the second, twice the product is minus 4x plus 2. You get yourself 4 x squared minus 4x plus 3. And I'll just point out that f of g of x is not the same thing as g of f of x. And that's true in general. F of g of x is not equal to g of f of x. Okay, so we say these compositions of functions are not commutative. Okay, and hopefully you've met that word before, but commutative means the order doesn't matter. So 3 plus 2 is the same as 2 plus 3 because addition is commutative. Okay, 3 multiplied by 2 is the same as 2 multiplied by 3 because multiplication is commutative. But 6 divided by 2 is not the same as 2 divided by 6 because division is not commutative. Okay, and neither is composition of functions. So the last part then of question 3 is for what values of x is g of x equal to f of x? So there is one particular value where this works, and how do you find that? Come back here and you say, when are these two things equal to each other? Sorry, there'll be two values where that's true because you're going to solve a quadratic to do that. Okay, you're going to say, when is 2x plus 3 equal to 4x squared minus 4x plus 3? And you move everything to the right-hand side, you get 2x squared minus 4x. 3 taken by 3 is 0. Oh, there you go. Okay, so that factorizes as 2x multiplied by x minus 2. So either x is 0 or x is 2. So at those 2 points, if you plug 0 or 2 into f of g of x and g of f of x, you get the same answer. Okay, but it's only for those two numbers. It won't work for every number, so they are not commutative as a general rule. Okay, so I'm going to ask you now to go and do questions 1 to 4 on page 240, and I'll see you in class tomorrow. We'll carry on with this exercise.